Hello, and welcome to Bay Institute of Science and Engineering. We are a full service precision machine trades apprenticeship training provider. We are certified through the Department of Labor to offer three different disciplines: precision machine trades, uh, tool and die making, mold making, die cast dies. These are apprenticeships in each one of these different trades, and we are, as we believe, the only online training provider that offers all three. In addition, we also offer articulated college credits to a advanced mechanical engineering technology degree upon successful completion of all of our courses. Let's take a quick look at what we actually have and what we do. Our goal is to help apprentices become journeymen in each one of those different certifications if that's what they're seeking. The other part that we have is, if you look at our mission statement, our mission statement says meeting the needs of the precision machining industry by teaching apprentices real world experiences and applications. And one thing that you should note is this program was designed and developed and dedicated to a great friend, the man who got me started in my trade, as well as many, many, many apprentices in the trade, Roger Sustar. So thank you, Roger, for everything that you have done. Our courses cover the basics. This is a pre course, and these courses are set up so that you could get an idea of whether or not the potential candidate would even be a good employee for your company. So we have a mechanical aptitude test. We'll go through that a little bit and we'll show you what that's all about. We also have a basic shop safety course that allows anyone to take this course, and we offer it at a very, very low price so that everyone can take this course, and there's no concern with charges or costs. Our course series are broken down into approximately 3 courses in each semester or series. Each semester should take somewhere in the neighborhood of 144 hours. That is a state regulation, a Federal Bureau of Apprenticeship and Training regulation as well. So Series 1, Series 2, as you can see the different courses. Series 3, we get into some milling concepts, CNC milling, and that's provided by a group called Fanuc Systems. They also do our turning courses. We have a metallurgy course. We have the GD&T course. We have the Autodesk course, and this course is actually full right now, so that's why it's marked as out of stock. This is a Fusion 360 course, which is CAD CAM. And as we go through this is a die making course. This one's full. This one is full as well. Students have enrolled. Jig and fixture is full as well. We have a lot of students that are transferring from other programs and moving into our programs, and they're further along in their studies, so they've jumped into these courses. We also have SolidWorks program that's offered to our students as well. Just to give you an idea of what the courses actually look like, this is the pre-employment test, and in this case, this one's asking to determine this unknown measurement, and the individual would have to come in and select the correct answer. These tests are all timed. It is a 4-part series test: applied machine technology math, blueprint and mechanical spatial relations, mechanical reasoning, and measurement and inspection. This total test for all 4 of these subjects is about an hour and 20 minutes. Another question that we have in the applied machine technology math is one like this. And again, it's a print that they might see in the shop. We want everything to be related to an actual shop experience. So they need to determine what the size would be. They then move on to the next question, and each one might be simpler. If there is a formula that's required, we place the formula on there, and then they have to solve from there. So this gives them an idea of what they would run into in a shop. So just a quick view of the different types of questions that we would have in that topic. Let's jump over to mechanical spatial relations. In mechanical spatial relations, this is again is a print, but in this case, it's on this print what bolt hole circle dimensions is there for the 312 to the 320 holes, and they would need to know that. And let's move through and take a look at some of the others. Again, same concept, same idea. The students move through these. Each one of the questions are there, and they need to determine the answer for these. So let's take a quick look at some of the questions. Here's a block. They would need to determine which one of these figures would be related to this. Gives you an idea of the different questions that we have. And here you have another block, and how that block would look is if it's turned. Again, if you have a solid block, and what it would look like if it was flat. Again, a print and the questions that's related to those prints. Another print and the questions related to that print. In the mechanical reasoning spatial relations, we also have the different views that they would have to identify and how they are related to the print part itself. In the inspection, we have the micrometer readings. We would need for them to understand how to read the micrometer. So there's several different micrometer readings that they're going to see, the different types of measuring tools that we would have. Again, another micrometer reading, and I'm just moving through these relatively quickly, but you can see each one of these has a different micrometer reading that would be required for them to know. This is selecting tools for a different type of measurement and so on. There is another micrometer reading, another micrometer reading, and that would be that test. In the blueprint reading class, we have the prints that are in the book itself, and the students will go through and we give them a lesson, and then we move into the actual part that they would see and how they build that part from a print. So we go through it step by step with them. We try to help them understand the views that they would see, and this is just one of the videos that we would have for the learning experience, and this is how they would view this from the front view and how it would be viewed from the side and so on. So I'm just moving through this, showing you what the students would actually see. And then we would have something that would be like this. So you would see the front view, the side view, and the top view. And we go through each one of these. And it will eventually, as this is projected out, it will then open up. You see the view inside there, and this opens up into what you would actually see as the view when it is translated or shifted onto the print itself. And there you have that view as it's shown on the print, and it's projected from a part. And we go through each one of the different lines and the line types that they would have as they see that. In the applied math, we start out with the very, very basics, and then we go into the different concepts as we go through trig, geometry, and so on. Each one of the prints that we use are color-coded with the figures that the students would come up with. We show them how they develop the triangles. And each one of these are in color. So the numbers, as we start to develop them, you will see are going to coincide with the angles that are projected inside there as well. This is just another shop math problem. It is taken directly from their textbook, and the students go through and work out the problem with the instructor. So each one of these angles are found as we take them through step by step, and the formulas are color coded as well. So you can see as we develop this out and the angles that are developed, the colors or the numbers are going to coincide with the angles themselves. So let's see what those numbers look like. So you can see here we've got a height here, and here's the number that goes with that. And then we show them how to work that out as they go through it. We will actually show the numbers and the figures as it develops. And here you can see how the numbers sequence out with the angle that's in there and how they actually come up with the solution for each one of the different angles that are in there as well. And as you can see, this is how they solve for this angle inside here. It is color coded. With the GD&T, we actually take them through each one of these. We teach them perpendicularity, angularity, every one of the features that's required. We teach them all about feature control frames, how the part's inspected, how the parts fit, and why we use GD&T for fits as well as for the actual intent and purpose of each one of the features that are there and that are used. So as you go through this, you can see how we develop these courses or how this is used and the applications that we use with inside that. So this gives them a full understanding of why GD&T quality control is so important and how the piece parts have to fit together with each other and the concept behind each one of the different feature control frames that they have and why they're so relevant to the working of that part. Here we show a part and the reason for what we're creating for this one, this instance, this is symmetry, and how that part is inspected as well. So this gives you an idea on that, or that gives the students the idea on that, and the concept behind each one of the different feature control frames that we use. In the metallurgy course, we talk to the students about the different types of metals that we have, the purpose of alloying the different types of steels, and what the advantage is of alloying the different types of steels, the properties that we have within those alloys that makes one type of steel more applicable than another type of steel for the different process and procedure that they would be using the steels for. So as they go through it, they get a full idea and a full concept of the different types of processes that are used to make the steel, as well as the alloying agents that are in the steel itself and the properties that go with them. So that basically does it for the courses. Of course, there's die making, mold making, there's quality control in there as well as the other series of courses that I showed you. So I hope this gives you a brief and clear view of the type of coursework and how we teach the students the different courses. It is a total of 600 hours of technical related studies that these students would have to have. That is a Federal Bureau of Apprenticeship and Training guideline that's required. Thank you and have a great day.